Morning, good afternoon, good evening. How good, how good. Welcome everyone for lesson 12. We're going to pick everything that we learned about tokens. We're going to follow part of the methodology that we learned yesterday, very briefly, and start exercising, building things on our own. I have example extension that we might want to do in a token, for example, ERC20 volts. That is very close to what we have been working so far. For example, the ballot, right? That we could cast votes for ballots already deployed in the blockchain. We could deploy a new ballot with new proposals. Remember, here with this implementation of ERC20 votes, I'm bringing a way for us to use tokenized votes. So instead of one person, the chairperson, giving rights to vote, here we can deploy ballots that would use the token balance or the voting power of people as an expression, as a determination of how much each person could be able to vote. Okay, this should be an example of extensions that you might want to do. There are many extensions out there. If you check it, OpenZeppelin, there are many different token formats, upgradability patterns, extensions on tokens like pausable, mintable, burnable, whatever. Some of those we have used in the past. Some of those we have used in the challenge yesterday. And I'm showing a new one for us to discover how to apply. Okay, ERC20 votes is not the most important extension. It is just an example on how you would apply different extensions for your token. Okay, that's the idea for today's lesson. And it's going to be a very short self-contained lesson where we're going to see this extension, we're going to read the documentation, we're going to understand this extension. We are going to create some scripts for building this, for interacting and building this smart contract together. I'm going to show where I got this smart contract. We're going to see what is happening with a script. So I could be doing tests for this too. So we are going to understand the things by debugging, doing console log and all, so things get more clear. And then I'm going to prepare you for the weekend project that is building this tokenized ballot, very similar to what you did last week. Last weekend, you were using a ballot.sol, right? Here, you're going to be using a tokenized ballot.sol, and you're going to do the scripts for giving voting tokens, minting those tokens, delegating, casting votes, checking, you know. You can even reuse some of the scripts that you did last weekend, okay? Now with this slightly different version of the smart contract, okay? That's the objective for today's lesson. So let's get started here. Do you remember what was the vote distribution mechanism for the ballot we used it in the past week? I mentioned that briefly while introducing the lesson. It was a single person, someone similar to an owner, right? A contract owner that would be able to distribute those votes, right? In this tokenized votes experiment, we want to do it different. For example, every time that you complete your homework, you could receive 5 tokens. And then every time that you participate in a lesson, you would receive 1 token. Wouldn't it be cool? Everyone that is participating here, asking questions, answering my questions, laughing for my jokes. No, just kidding. You would receive 1 token. And at the end of the bootcamp, we are going to use these tokens to vote on who is getting a prize of $1 million. Would be cool, right? This is not true, but could happen. So if voting has this kind of power, people would want to buy these voting tokens, right? And then would drive the value of these tokens up. So I could be airdropping these tokens and using these tokens to vote on things. Let's vote on the best project. Let's vote on let's do a party at the end of the bootcamp. So let's vote on where the party is going to be. Let's vote on the food that is going to be given at the party. If you should put pineapple on pizza and also this kind of stuff. So we could use the amount of tokens as voting powers. But to implement that ourselves is a little tricky. Tokens, the ERC20 tokens, are not very good ways for us to account for voting powers. There are many different things. I could buy a token, vote with it, and then sell that token. I would spoil the whole voting process if this is not done with care. I could exploit the voting. I could use different tokens to vote again and again. I could use NFTs to vote, but then it's more tricky to handle NFTs. So this extension is going to handle all of that for us. So going for this first link here, we have the explanation of the ERC20 votes. Okay, and let's read that with attention. This extension is going to keep a history of checkpoints of each account's vote power. So each address in the blockchain would have a number related to the voting power that would change in history based on checkpoints. By Monday, you have this amount of voting power. By Tuesday, you have this other. And now it changes over time. Okay. So you can delegate this voting power, similar to what we had in the ballot smart contract last week, by calling the delegating function to delegate to someone else. Or you can you can either call this function directly, or you can provide a signature to someone using a smart contract called permit, so that you delegate by signature for someone else. We're going to see that in just in a while. The voting power of someone of one address can be queried through a public access, so someone can ask the get voting power of the person now, and the get past votes of that person now. Okay, so these are the functions that we're going to see in the ERC20 votes. Let's see if I find these. Function checkpoints. Wait. Get votes. Yeah, here. So get votes, get past votes. We have all of the normal functions of an ERC20, like balance, like name, like total supply and all. But here we're going to see those other, they move it where those descriptions are. Sorry about that. We're going to see those other functions: get vote, get past vote, that would pass an account, time point in the past. Okay, and that is a technical detail here. By default, this token balance is not conversible, is not related to one voting power directly. If we did that, we would spend a lot of gas, a lot of computational power wasted computing the changes of voting power again and again and again every day, while I just need the voting power once a week or once a month or once a year or every 4 years if it's like presidential elections. So why would I account for the voting power changing again and again and again every checkpoint if I just need it to vote in a very distant future? So the way that this smart contract was designed is that for making the transfers cheaper, we do not account the voting power at every transfer. We only account the voting power when a user activates it by delegating those tokens to themselves. And this would activate the checkpoints and then would get the voting power tracked. Okay. So that's the design. The intended design. Okay. Another technical detail is that the a normal ERC20 token would allow a balance of up to 2 at the power 256 minus 1 of value stored in account. Here, this maximum supply is reduced a little to 2 at the power 208, which is still a very big number, but you should account for that because if you try to go over this, if you're doing like a meme coin that has a really, really big supply, you might be capped on this, okay? Good. You have questions here, Dante?
Yeah. What you're saying is that that just because you have the right token, um, you still can't get your vote won't you won't have voting power unless you're delegated, even if you have the correct token for, I guess, what you're checking the token balance.
Exactly. For example, in this hypothetical scenario, you have just received a token, right? You have asked a question, you're going to be dropped a token. So have it there, your token. So I would pay a little more gas to activate your checkpoint with your new balance. And tomorrow you're going to ask another question. Monday you're going to ask another question. You're going to be interacting with this bootcamp, doing your homework, and now every day. So I would be paying gas every day to update again and again and again your voting power, given that you only need this voting power at the end of the bootcamp. So why would I pay gas 10 cents here, 10 cents there, and now again and again and again within the whole bootcamp, giving you this airdrop, accounting your voting power increasing day by day if you only need in the end. So what you're going to do is collect all of this money within the bootcamp, this hypothetical scenario, and then at the end, before the voting, before of the ballot of the final decision, you would delegate to yourself and you would activate this checkpoint. Okay.
Got it.
This is a yes, that want to ask something before. Okay, Marco, you have a question?
Yeah, I got a question. Since you told that this is an extension, so it's not inheriting something from the ERC20. Otherwise, it will be fungible votes, right? It's completely different.
Yeah, this is an extension on ERC20s. So it has fungible votes. Yes. I could vote with a 0.1 token instead of 1 unit of vote all the time. And it's meant to be used with an ERC20. You see here?
Okay, so it's going to inherit all the things from the ERC20, right?
Yeah, yeah.
Okay.
It's going to inherit and modify things on ERC20. Okay. This is a very good example of a documentation of a smart contract. It's not that clear what is happening here yet. You have some idea, maybe you have a very good idea, maybe you are clueless of what this is doing yet. And we have 3, 4 paragraphs, and we should figure out. People, you don't know how common this is. A very big protocol, the Blaster chain, ultra power, megazord, blah, blah, blah. And then you go for the documentation, 4 or 5 paragraphs. Did this and didn't do that, and only supports one operational system. And the DevRels are there throwing parties. They don't want to explain things. Okay. Open Zeppelin documentation is one of the best out there. And still, the documentation is very short. Who can save us there? The Superman? No. Who can save us there is this process of running this on our machine, touching things, see if they break. Okay, I'm going to give you the way for you to understand all of that. Okay. Before we start, let me mention this ERC20 permit too, that is very cool. ERC20 votes uses that signature stuff from the permit. So this extension, which is a very common extension, allows you to emit approvals to other people off-chain without paying gas using signatures. Remember that at the end of yesterday's lesson, before burning a token, I would need to approve first for the contract to be able to move my money. If I'm interacting with another smart contract with an ERC20, I always need to do an approval first and then call the function. Approve first and then call the function. Approve first and then do transfer from. Approve first and then do burn and then do stake. It's never possible to send a token, ERC20 token, directly to a smart contract. We need to approve, and then the smart contract would take our money. The thing here is that when we pay this gas first, for example, we receive an airdrop for a token, this voting token, for example, and then I wanted to use it. I need to have the network token first, and sometimes I don't have the network token. So when I can do this signature, I'm going to sign this off-chain with my wallet, whatever. I need to interface with a smart contract so I don't pay gas. And I send the signature over email, over WhatsApp, over Telegram, over anything that I want off-chain to the person that I want to use, or even to the smart contract that I want to call. And this method would allow us to change the allowance of that account by presenting a message signed by the account, okay, and with some guardrails to specify the spender, the value, the deadline for that spending, so that only that person can use that permit in that time, that smart contract, and you don't need to pay gas for that. Of course, if you leak this signature, it can cause problems for you. Okay, so people could steal your money. But if you keep it safe and you send to the person that was supposed to use that, you are okay. You are giving this permit there, and that person would be able to use even though you didn't put that on chain. This is the design of that smart contract, okay? It's not going to be important for today, just mentioning that it exists. Since we have this delegate by SIG explanation here, is interesting to know that we have that, and you can apply that on your smart contracts when you want to do when you want to have less friction, okay, for your end users. Here, this version is changing a little, so we would have the backwards compatibility problem. Sometimes the major releases would change the like the design, for example, the ownerable contract used to have the MSG sender in the constructor as owner, but now they have changed so that the owner of a smart contract should be defined as a parameter in the constructor. So some small different functionalities that you might find on different versions. Okay, so I'm going to show you the wizard. I mentioned about that last week too. That is a tool that allows us to build smart contracts. Okay, so you want to build a stable coin, you want to build a real-world asset, want to build a DAO, whatever. You have many different ways to build these smart contracts here. I'm going to use the wizard today to build a voting smart contract. A smart contract that keeps track of historical balances for voting on-chain governance. I'm going to use the block number. That would be like the default version of it. It's possible to vote by timestamp too, but it's a little more tricky, it requires more code. And this is what I have. I'm going to make it mintable with roles. Okay, so if I pick those configurations here, mintable. Let me see if I have permit. Yeah, I should have permit. I should have access control. For some reason, it's asking me for nonces too. Function nonces. It's here. Yeah, it's missing on my smart contract, but it's here. I'm going to use just for the sake of having it correct. So this is the suggestion from OpenZeppelin to build a mutable with access control role, the smart contract with votes using the block number as a way to express durations instead of timestamps. Okay, so go there for the wizard now. Copy this here in the chat. And this is going to be your smart contract for today's lesson. Okay, it's going to have access control. It's going to inherit ERC20 from the normal implementation of ERC20. And then it's going to apply ERC20 permit and ERC20 votes on top of it, as we have here. Okay, this is a somewhat complex inheritance structure because there are some things defined in ERC20 permit that ERC20 votes would use. Okay, so OpenZeppelin already solved that for us. They put the following overrides required by Solidity to compose those smart contracts. So they already create this function update that is needed, solving the overrides in ERC20 and ERC20 votes. And they already put this function nonces here, solving this clash between ERC20 permit and nonces that would be used by the ERC20 votes. I guess the version that I had here was importing nonces from, I guess it was in the token contract itself. Now they separated it for the utils. Okay, interesting. A slight difference. Okay, this is going to be the smart contract. Why should we resolve this with the super blah 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 here and now? It's not important. Okay, people, I mentioned that last week when speaking about inheritances, when you apply a lot of contracts on top of each other, the base, the most derived and all, that sometimes one could override the behavior from the other. And then Solidity asks you to explicitly define those overrides, okay? Like this. If you don't put this code of block, things are not going to work, okay? So this is the smart contract for today. Everything that we're going to do in the next 30 minutes or so is just using scripts to understand that smart contract, okay? I could use AI to understand this. Yes, I could click here and then ask like, why should I override these things and then call super. So I don't know if the AI is going to answer correctly, but I'm just joking. The correct way for us to understand that is not calling AIs and chatting with ChatGPT. The correct way for us to understand these things without the risk of hallucination is to test them directly. For example, we could deploy that on Remix. We could interact with it in a test net. We could interact it in a local network. I'm going to do that with scripts because this is what we have been learning in the past week, okay, since last week. So for that, I'm going to copy a project. For example, I'm going to copy everything that I have inside token sale. I don't need the artifacts. I don't need the cache. Actually, I don't even need the contracts. I don't need the ignition. I don't need the scripts. I don't need the test. I can create all of that myself. Okay. I'm going to copy these. And I'm going to create a new folder. Tokenized ballot. And I'm going to paste these files here. I'm going to create a new folder for contracts. I'm going to create a new folder for scripts. I could create a new folder for test. I'm not using test, whatever. And this would create a blank state for me to start today's lesson. Okay. This would be the same thing as copying the folder and deleting everything that was inside. Doesn't matter how I do it. Okay. I'm going to install, and I have my project ready for today's lesson. It took me less than 1 minute, and this is the kind of practice that I want you to have. Every time that you want to start a new project, it shouldn't take more than a couple minutes for you to create this base structure and start working, because it can be quite often that you need to create a project for testing something, testing a smart contract, testing a swap, testing a DEX operation, something. It's very common. You start a new project, you put some contracts there, and then you use it for simulating, for studying, for designing what you want to do. Okay. So here I have this new project. Yes, Arda?
Do we need to install OpenZeppelin contracts too?
It is there.
So
If
I noticed when we install OpenZeppelin contracts, it also does it also install all of the npm stuff?
So when we add OpenZeppelin contracts there, we copied this package.json from the past lesson. So when we add OpenZeppelin contracts in the dependencies, whenever we install it with npm, it would install everything. Okay. Good. Okay. So you should have a project like this. If you want to code along, if you want to test the things that I'm doing on your side, you should have a project with this kind of a structure, similar to what we did in the past lessons. And you can start testing these things on your device too. Okay. Browse, the OpenZeppelin is in my package.json. So when I do npm install, it already installs everything for me. Okay. It already installs all of these dependencies. Okay. I'm going to open this on Cursor. And we're going to start coding. I'm going to start playing with it. While this loads, I'm going to copy this smart contract. And let me copy this. And let me update the description for today's lesson. This is wrong. This would be correct.
Can I go?
Rose, I guess you have an open mic. You want to ask something?
Thank you.
Trying to solve this. So which lesson I'm at? 12. Okay. Let me ask the AI to generate the message. Okay, good. It's committed. If you clone the repository, you should see the changes there. So I'm going to use this version of the smart contract as proposed by the wizard. I'm going to create it. Yes, Johnson?
What is that command, vi package.json? Is that when we install npm I is automatically coming, or do we need to use that command?
I was using this comment to explain for Arda, I guess, if I recall correctly, sorry, but just a minute ago, that inside the package.json, I do have here this open
Okay.
Zeppelin contracts.
Yeah, yeah. Okay. Understood.
Okay.
Clear.
Even I guess I did. Let me see.
What is the name of this contract that you just re-updated on lesson 12?
We can name it my token. Okay. We can name it my token, just as we did yesterday. We had a contract, a token called my token. I'm going to create a new one. My token.sol. And if you want to use yesterday's project, you could name it something else, my vote token or something like that. Okay. So this would be the smart contract. Where I got this smart contract? Here from the wizard, the Open Zeppelin wizard. Okay. This commit should have gone through. It should be there in the GitHub. Okay. And just to review on this update stuff here, if I remove this thing, if I remove this, I'm going to have this problem. Solidity is complaining because I have a derived contract that must override the function update, but there are two or more base classes that will define the same function with the same parameters and the types. Okay, so you just need to this is not changing the behavior of the smart contract. Okay, you just need to appease the need of bureaucracy from Solidity and put the functions here, but the correct override order here so that a Solidity checker is chill with it. So it was complaining that you might be doing something wrong. Now, it didn't change anything of how the smart contract works. You just, this is just sending a message for Solidity compiler saying, I know what I'm doing. And then the Solidity compiler is going to trust you and compile that smart contract. Okay. So you don't need to worry and wrap your head on this. It's given already. It's there. It's safe. It's working. So you don't need to worry with this. Okay. To understand the ERC20 votes entirely, we would need to read the smart contract. We would need to go through all of those changes. What is a checkpoint? What is a vote? And then I would need to understand the checkpoints utility, the nonce utility, and all that. That could take a little while. And there's a lot of complex stuff going there now. Or we could do the way that we learned this week. I can create a test file, or here I'm going to do scripts just to make sure we review the running script spot. I'm going to run a script called test vote token.ts, or you can name the script whatever you want. I'm going to name it test vote token because it's going to be a script to test the vote token. Okay. Writing scripts. Just to review this technique because we're going to need in the weekend. Okay. Let's see what is happening here. And 12. Okay. I did not sync the changes. Sorry about that, Ivan. I have a lot of repositories open here. Okay, there you go. You should see the new versions here. But actually, you can also pick from the wizard. So don't worry about that too much. Okay, if you go for the wizard and you pick the features of mintable, permit, and votes with block number, it should give you the same smart contract too. Okay. It's good that you get used to the wizard, okay, people. It's like building a smart contract like you build your Subway sandwich. I want extra bacon, double cheese, no lettuce, and then you have the sandwich at the end. And if the sandwich is not tasting well, it's your fault, right? You you picked the wrong ingredients. So the same experience here. You build your smart contract just by checking the checkbox. And within this bootcamp, we might learn most of these things, these features that we can put, the upgradability patterns, the transfer proxy, the UUPS, okay, until the end of the bootcamp. So let's create some scripts. For example, let's create a main function. Let's even copy that from the past lessons. Maybe we had that, for example, in the lesson 9. Remember, we had these scripts to test things. So this main function with the public client, with those get wallet clients and all, you can copy this structure whenever you are writing a smart contract. Okay, and copy this structure whenever writing a smart contract, no, whenever writing a script for testing smart contracts. Sorry, this is not a smart contract. This is a script for testing smart contracts. So you can copy this structure for whenever you're writing a script. Okay, a main function, and then you're going to catch this main function for you to do something with the terminal. And if you have an error, it's going to come here. Okay, so let's start from here. Then we're going to have the public client. We're going to have the deploy account 1, 2, and 3. We're going to deploy this contract called my token. And we're going to log something like that. Token contract deployed at this address. Okay. Ayodeji, you want to ask a question here?
Yeah. When you said we can copy the script for anytime you want to write a smart contract. So I want to ask, it doesn't determine if you are trying to write NFT smart contract or any smart contract. We can just copy and try and adjust it to our own script.
Yeah, I meant whenever we want to create a script for testing a smart contract, you start with this starting base. So it is a public client, you have those accounts, and with here you can do anything you want. This is your test bench. You can deploy smart contracts, you can send transactions, you can trigger execution in all these smart contracts and so forward, okay?
All right, thank you.
Okay. This is the starting base. Let me disable my cursor. I do have all of the needed snippets for today. And if I execute that script, I'm going to go for the terminal. I'm going to run this command npx --hat run scripts test vote token. We're going to do the same thing that we did on Monday. We're going to deploy a smart contract to my local testnet, compile and deploy, and then I can start playing with it. What happened? What? My token, I need parameters to this token. Okay. Yeah, I should have checked that before. Because in the smart contract that I suggested before, I would have the MSG sender as the default admin and the address as minter. They did change that in the recent versions so that instead of picking the MSG sender as the constructor, we need to pass it as parameters. Okay. Well, what is done is done. Let's follow this suggestion. So my token here would need 2 parameters. Actually, let me see. Actually, it's going to be better to just change
what
here.
would those be?
Those would be the addresses of people that you want to give the default admin to, and the address of the person that you want to be the meter. Okay. So I would prefer to just pick MSG sender. The deployer is going to be the admin, is going to be the meter. Okay. I guess this is going to go better. And I guess I don't even need the meter here. I might go without it because I'm going to give, let me see. Yeah, I do need the meter. So I'm going to use this smart contract. Okay. We'll use this smart contract. This was one of the changes. There is no big deal. It's just design change. Instead of assuming that the MSG sender is going to be the meter all the times, they would receive it as parameter in the constructor, which is a good design change. I could pick that on the go. Just to keep what we have been doing in the past lessons, let's keep the MSG sender on the constructor as the owner, as the address that is going to comment everything, okay? And that would work. I should have checked that before committing. Sorry about that. I'm going to fix that right now. Just made a change here. I'm going to make another change. Now it should work well. If you want to keep the design of asking an address in the deployment, it's not a bad design, okay? I agree that this was a somewhat good change, a good design change. It's just that I've been using this version for 2 years now. Let's keep the way that I have. You understand what is going on. And then those scripts are going to work, okay? So now when we run this test, script, it should work correctly. And it should say that the contract was deployed at that address, okay? Good. Without any problems, without passing any parameters, I do have my contract deployed now. To avoid this extra complexity. Okay, this is formatting the string. Okay, do not use normal quotes, otherwise this is not going to work. We need to use these backticks so that I can format this string and print the correct things. So let's start testing some things very, very easy, straightforward, as we saw on Monday's lesson, as we saw in the exercises. Let's mint some tokens. So minting some tokens. Copy this. So I'm going to pick the account 1. Did I name them like that? Yes, I did. Account 1 and account 2. I should stick to the same naming. Account 1 and account 2. I'm going to pick account 1 and I'm going to mint some tokens. I'm going to pick the deployer actually, and I'm going to mint some tokens to the account 1 address with some mint value here. Okay, this mint value is a constant here. We did that in yesterday's test scenario. You can just define a constant here, like const mint value equal to 10. This is going to mint 10 tokens. Is this correct or is this incorrect? left this out of the explanation on purpose. You should have learned that already. Yes, Dante.
What about parsed error or parsed ether?
This
What is
would
that?
go from a string to big int. We used that last lesson, remember? So we could use parse ether to come from these weight units and like say that instead of just minting 10 units, you're going to mint 10 entire tokens because we have all of those decimals, remember? So if we just put 10 in, it is wrong. We would mint only 10 decimals. We actually need the whole 18 decimal cases here for minting one token. Okay. And if I wanted to display later, I could use the format ether from VM to display that. Okay, keep that in mind. It's going to be important for future lessons. Okay, converting back and forth from numbers to big numbers and all. Okay. Dante, you can claim another token. Browns, thanks for answering. You can claim a token. Okay. Imagine if that was a thing. So I'm going to mint these tokens and then I'm going to log. Let's go for the terminal. Let's run this. So the contract was deployed this, and I'm minting 10 with 18 zeros, decimal units to this account. So this account has 10 blah, 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 decimal units of my token. Okay. Is this clear for you? Dante, you remember about this, right? Those functions, parse ether, format ether.
Yes, I do.
Wonderful, thanks for confirming. Okay, so up to this point, we have nothing new about tokens. It's behaving like a normal token. I mint, I have a total supply, I can transfer, I can approve, okay? It's like a normal ERC20 token for us so far. But now let's check the voting powers. Let me put this. I'm going to call that smart contract. Checking the vote power. I'm going to call this smart contract to read the votes from account 1. Account 1 has just received 10 tokens. So how much of voting power account 1 should have? 10 token, 10 voting powers. 5, 100, 0, -1, 42. 42 is a good guess. No one is with me on 42. Ivan says 0, Nathan says 10, Trust 10. It would make sense, right? I received 10 tokens. I have 10 tokens of voting power here. It would make sense to have 10 voting powers when I check, right? Let me do a clear first and then do this. It's going to be more visual. Increase the zoom too. Didn't help, sorry. So it has 10 decimal units. Now let me save these changes that I did into the scripts and let me run it again. So I had 10 tokens of balance, but still I would have 0 of voting power. It's a technical detail, but I explained that before self-delegating, I still have zero units of voting power. I will need to activate this checkpoint for me to have voting power on my account. Okay. Arda, you want to ask?
Yes. So while we were deploying the contract, which parameters did you pass in, please?
I changed the smart contract so that I don't need to pass parameters anymore. Okay. And I have committed those changes to the repository.
Oh,
So
okay,
that
I guess
instead
so.
of passing the parameters, I can just use the MSG sender.
Okay. Yeah, I think I need to refresh the thing. Okay, thank you.
Okay. In this situation, you're going to change 3 lines of code. So instead of copying over from there and pasting here, maybe you want to exercise doing those 3 changes, right? So you take away those parameters from the constructor function, and then you replace them here with MSG sender. Okay. Why is this happening like that? Is the contract broken? No, it is a design choice for making the transfer cheaper. So when I transfer to someone, I don't need to account for voting power all the time. I would save some gas. Okay. Let's do the self-delegation with this transaction. Let me do a self-delegation. So I'm going to create a delegate transaction like we created a mint transaction a while ago. This delegate transaction is going to come from the deployer and is going to call delegate. Actually, no, it's not going to come from the deployer, okay? It's going to come from the account 1. I have this parameter here, account 1. So I'm calling this delegate transaction from the account 1, delegating the balance as voting power for the account 1 itself. Okay, so it's like this. I'm shaking my own hand. I trust you. Then 2 taps in the back. Go and vote with my voting powers. And then I say, thank you to myself. Okay, this is just a transaction that I do now. I pay the gas for this transaction for activating all of those checkpoints. And then after I do the delegation, I would see my voting power. Let me show that for you. Okay, so before self-delegating, I had 0. Now this account has 10 tokens of voting power. Okay. Is that clear for everyone? This is basically the only addition that ERC20 votes is going to make on top of ERC20. Tracking votes for us to do these delegations here, calling this function voting power. Okay. If you have questions, feel free to raise your hand now. But this is basically what we wanted to understand for today. Okay. We also have the possibility for sending these tokens for someone else. So I'm going to experiment with the token transfer. Let me copy this block. Token transfer. And I'm going to do this transaction. Coming from the account 1, I'm going to pick the contract and do a transfer transaction. The transfer is a normal ERC20 transfer, okay? That is going to send half of the mint value that I determined, like if it was 10, it's going to send 5 of these tokens from account 1 to the account 2. Okay. Then I'm going to get the amount of votes from account 1 and the amount of votes from the account 2. I had, explaining again, Browns. I had 10 tokens here. Okay, this is what I'm seeing here in the terminal. I had 10 tokens here. Okay. And then I self-delegated so that I have 10 units of voting power. Now I'm going to transfer from those 10 tokens that this account 1 has, I'm going to transfer half of it, 5 tokens, to account 2. Imagine Bob and Alice and Bob here. So Alice would have 10 tokens, transferring 5 to Bob, and then how many tokens Alice would have? How many voting powers would Alice be entitled to? And how many would Bob have after this transaction? Okay, that's the statement here, Browns. Won't you run that on your side and tell me what is the answer? Would Alice have like 10 voting powers or 5 or 0? How many voting powers would Bob have? If
Alice 5 and Bob 0.
Interesting. Did you run that yourself, Ivan? Good, good. Let's see if that is correct. So the account 1 had 10 tokens, correct? But then when transferring out, I do update my voting power instantly. I don't need to self-delegate again to account that I lost voting power. Because if I had to, things would get tricky. So when I transfer tokens out, it automatically updates my voting power. But when receiving tokens in, like here, it does not update my voting power directly. I would need to self-delegate with the account 2, and then I would see the voting power for the account 2. Okay. So at the beginning, I had 10 tokens minted. The total supply was 10, but the total voting was 0. And then I activated my voting powers. The total supply is still 10, but now I have 10 total votes. Now I transferred out. The total supply is still 10. I'm not minting new tokens, but now the total amount of votes is only 5. See, the total amount of valid votes can go back and forth depending on how people self-delegate their votes or no. Okay. And if Bob would want to activate his or her, Alice, whatever, votes here, I would need to do another self-delegation. Like I would have a self-delegation transfer or delegate transfer 2 that would delegate to account 2 address from account 2, waiting this transaction received, and then I would get the votes after 2, and then I would see that I would have 5 votes after self-delegating again for the account 2. Okay. So it is compatible with the transfers from the ERC20. At the same time, it is compatible with all of the accountings needed for the voting power. And also I can get past vote, like get past votes. Token transfer, name it like past votes. I'm going to do a small loop so that I'm going to go block over block for those past blocks that I have in this local chain. And I'm going to print what was the past votes for this account one. Okay, I guess I had a question from Laurent about what is big number. So whenever we are using these N notations here.
I wanted to know what means BN, but it's big number, so
Okay.
it's more down to earth. Sorry.
No worries, no worries. I used it somewhere, right? BN here, yes.
Yeah. So
Yeah.
now I know.
Yeah. Because sometimes we do like this, and then const balance equals to format ether, and then balance BN. So that would be the balance without big number, you see?
Yeah, okay.
It's very common. I guess we even did that lesson 9, I guess. My memory is failing me. So going back to this loop here, I'm going to pick the current block number, and then I'm going to loop back for 0. So starting from the past block number, I'm going to get the past votes. Let me run that script again. Okay, so going forward in history, I had 0 tokens, minted 10, I have 10 of balance, but 0 voting power. Then I self-delegate, I have 10 of voting power. Then I transfer 5 out, I have 5 of voting powers. And the second account would have 0 of voting power after receiving the transfer. Okay, so at the block 3, we have 10 voting powers. At the block 2, after the minting, I have 0 of voting power. And at the block 2, at the block 1, before minting, I have 0 of voting power. So I can pick historical values of voting power to bypassing the block number as the parameter for getting the history of that person. So if I want to make a ballot using the voting power that I had yesterday or 2 days ago or last week, I can pick these historical voting numbers. This is very useful for creating snapshots, so that if people want to rush in and buy voting tokens, they can't. They would need to have done that in the past. Okay, so they don't know that there is a vote coming. Everyone is okay with their lives and all. And then I would have my votes here activated on the Sunday and all, but all good. And then in the Monday, they announce a voting. Okay, we're going to vote for something very important. We're going to vote for the flavor of ice cream that we're going to have. Because allowing people to decide by themselves is too dangerous. We need democracy for that. So we're going to vote and everyone is going to have the same flavor. So we would rush in and pick our favorite flavors and all. And if we really want to have a flavor to win, we would maybe buy all the tokens. I'm going to buy 10 tokens from you, 5 tokens from another person, and all. When I define a cliff period, a target of time in the past, I can inhibit that. Either people would be paranoid buying tokens all the time, or they would just accept that they don't have enough voting power and they would vote with what they have. Okay, so this is the design for the ERC20 votes extension. Okay, any questions up to this point about the token itself? About these functions that we put? There is no voting involved yet. It's just accounting for voting powers so far. Okay. Yes, Ivan.
I'm a little bit confused that so the user 2 or the account 2 would still have 0 at the end of the last block. And is this correct that as soon as account 2 self-delegates, then it will get this 500 which were transferred? Or does it need to self-delegate before it receives any voting power?
It would need to self-delegate after. So here, the receiver of the transfer still has 0 units of voting power. I would need to add another self-delegation. Let me do that. Self-delegation. Just self-delegation for account 2. So delegate transaction 2 would write the delegate from the account 2 to the account 2. And then I would wait for this delegate transaction 2. And then the votes after 2 would read the votes of the account 2 address. And then I would say after self-delegating. Okay. Before self-delegating, I've received this transaction, but I still have 0. So when I self-delegate to myself after receiving these 5 tokens, let me see how it's going to go. Now I have it like that. I had 0 units of voting power after receiving the tokens, but this account then I started having 5 units of voting power after self-delegating. Okay. Makes sense? Well, maybe still thinking, let me know. And now we can see one extra block here from the account 1. In the block 4, it had 5. In the block 3, it had 10. In the block 2, it had 0. In the block 1, it had 0. Okay. Arda, question here?
Yes, is there a function so that we can learn when the voting power of some person changed, that is the block number when the changes happened? Is there something like an index array that holds that, or do we have to run a for loop every time?
Yeah, it would have all of the checkpoints. Every trans would create a new checkpoint, and you would need to iterate. There are loggings that you can do, those transactions that would create events that you can go through those logs to make it more efficient, but here we would iterate.
Okay.
Okay. Browns, you have a question?
Yes, I have a question. Okay, so for when we're converting the account that we divided by 2n, can we not just wrap it, that 2, can't we just wrap it with comma it, like the import statement that we use? Why can't we?
It means here.
Yes, exactly. Yes.
So you are asking why did we divide it by 2?
No, like why can't we not wrap it with formal it the same way we did it for the constant variable on top? Yes.
Here, the parameter for the transfer function should be one address and one number.
Okay.
And here we would do the pass ether for 10. But okay, maybe we could do something like this. Maybe it's going to be more visual. Then I'm going to transfer only 3. Okay.
Yes.
I could. Instead of picking the number that I had, and then
Okay,
I would
let's
change it here. And then I would transfer 3 out. So I had 10, Now I have 7, went
Okay.
for 0. Then the other person had 3, I had 7, and that goes.
Okay,
I
thank you. I
covered it
really
by 2 just for make it quicker.
thank you. Thank you.
Ivan, you still have questions here?
Yes. Yes,
Okay.
please. When you are printing the history by block, can you change it on your side from account 1 to account 2
Let's
and
do
run
it.
it again, please?
Maybe I can do one after the other.
Yeah, I know, but if you just run 2, because if I run 2, I always get zeros even in all 4 blocks. So you just, okay.
Oh yeah, that is true because you might not have this code block
I
here.
have put this code to self-delegate, and I get this line saying to me that I have half of it. But then when I do the past votes, it's still zeros. So this is why I'm saying,
because we are starting the previous block. If we start in the current
oh,
block, let me do that. No,
aha,
I guess
okay.
maybe maybe it's not going to work because I cannot get past votes on the current block. This
That
would
is
give me
right.
an error. Let me test.
So I need to create like a fake vote block doing something completely unrelated.
Yeah, look, I cannot get the past vote on the current block. So this is a
Yeah.
problem. Yeah, I need to pick. So this is why you're not seeing this last transaction in the history, because we are using the get past votes. Okay.
Understood. Thank you.
That is a way to force mining a transaction. You're going to see that in future lessons too. On your local node, of course, not in the public testnet. Okay. Yes, Arda?
Yeah, so one more quick question. If in the test files we don't define these variables as constants, what would be the problem?
So here we define them as constant in the top, just so that if you want to move this later as receiving that as a parameter in the script, or if you want to quickly change those numbers to see how it goes, later we're going to see some techniques for smart contract security called fuzzling, where you try different parameters like this. It is always good to extract them in your code so that you have one place to change and it reflects everywhere else. Then actually going through your code, the changing here to 10, and then you have another constant show up there in the middle. It can cause confusion. The best way is to have all of the settings in the top, and then you just need to parameterize these settings or change them in configurations and all, or pass them by parameters to this script, so that you don't need to go through the lines of code for changing variables. That
No,
prepared you.
Okay, so I'm perfectly understanding that, and that's the way to go for sure. What I'm asking is inside the main function, for example, like in line 14, mint transaction. I mean, I might want to use another mint transaction once again. And then if I write it like this, then I'll have to write in mint transaction 2. So
Yes.
why are we using the constant in line 14?
Okay. Yes, you could have like, I even did that in past exercise, like, let me see one that I have very quickly.
So is there like a TypeScript pragmatic thing, or
no? It is just let me show you one that I did yesterday in the token sale. We had the test. Sorry. And we had the token sale test.
Mm-hmm.
So in this test, we did this. Grant my mint roll payment token contract transaction. And then I have this transaction here. I could have done just like let transaction equal to that. It is true. I could, and then I could reuse this transaction again and again and again. It's not a problem. TypeScript would accept, I could. It's just that having those different constants there in memory, they only consume a little place on the memory of computer. And when we stop to debug, we can see a snapshot, a picture of the memory, and we can hover over it. Oh, this transaction is like this transaction is like that, and the name of the variables would help us. This is mainly for debugging. The naming of the transaction would help us to get a scoop of the state of the things as we are debugging, as we pause into the debug console, okay?
Okay,
If
so
you use the same transaction for everything, the same variable for everything, you lose the history of those other variables.
Okay, makes sense. Thank you.
Glad that you noticed it. I do those things by habit. Sorry if it may be confusing, like why I take those design decisions. Just by habit of doing these things again and again for a lot of time. I don't even notice that I'm doing that. This becomes so common that I take these design presses while I'm coding. So for these last 10 minutes or so, I wanted to draw your attention for the weekend project, because we're going to create a tokenized ballot now that is similar to a ballot that we had in the past, but we have some different structures here. Okay, let me copy this smart contract. Let me create this smart contract called tokenized ballot.sol inside my cursor, in my contracts folder here. So it's going to be the tokenized ballot.sol. Okay. And it is a little different from the ballot that we used in the last weekend, that we saw in the last week. I do have the structure of proposals here, but I do not have the structure of voters. I don't have the function delegate here. I just have a function vote. And the function vote is taking two parameters, proposal and amount, instead of just proposal. Okay. You see this difference in the structure. The thing here is that now that I have a token to correlate the voting powers, the delegations, I don't need to store this information in the smart contract of the ballot anymore. I don't need a chairperson. I don't need the mapping of voters. I don't need the delegate function. Most of these things are handled by the token myself. The only thing that I need to do is to save a token contract address here on line 14. And whenever I want to use this token contract, for example, here, or for example, there that we're going to use in the future, I refer to this external call to that token to get my past votes, to get all my current votes maybe on that smart contract. Okay, I still need the array of proposals, but whenever I want to get the voting power of someone, I don't get the weights inside the voter struct. I would get the voting powers inside the token contract itself. Okay. Does it make sense? Now I can create a ballot smart contract that is going to host the votes that I did, and I can consume those votes inside this ballot. Okay. We have a small to-do. This is part of the weekend project too. In the weekend project, we're going to write these scripts, but the idea is that you would complete these contracts together with your group. Okay. I'm going to show the solution. I'm going to guide you through the solution here. But ideally, I'm not going to send that for you. Ideally, you're going to code that together with your group to understand what is going on, to understand the voting mechanisms, and then you're going to create those scripts on your side. Okay. So the settings are like this. When I deploy this smart contract, I'm going to have this array of proposals, just as I did in the past ballot. I'm going to attach this ballot to a token contract, and this contract is going to govern the voting powers for each person. And I'm going to have a target block number as a cutoff date so that I would have a cliff period from the dates of the number that I would have as the date of the voting powers as a snapshot and the actual voting time so that I would avoid people from buying votes from each other. Okay, so this is the initial configuration. Arda, you have a question before I begin the vote function?
I maybe I missed something. How do I see who has voting power from token contract?
For example, here, as we did in the lesson in the line 30, we can call the contract and ask get votes to see the voting power of that person.
Okay, but there is no list that keeps who can vote, right?
Yes, there is no list that keeps who can
Okay.
vote. But here, I'm not going to need a list. For example, a person is calling this function trying to vote. And at the end, what I want you to do is pick the vote count of that proposal at the position proposal and increase by this amount, right? This is my objective with this vote function, correct? But I need to check something first. We do have time. We do have more than 5 minutes. Let's do this together. What I need to check before doing this line 33, before increasing the vote count of that proposal?
The voting power of the account.
So to do, I need to check the voting power of that account. I need to check the voting power of the account calling this function, right? So, for example, I could have a function get voting power that would receive an address voter. Let me make it public. It is going to be a view function which returns uint 1 uint 256. Let's name it vote power. Okay. And how do I get this vote power? Suggestions? Or to actually implement that line by line?
From the token contract?
The token contract. Okay, how do you do that? You need to make an external call or something like this. Marco suggests that I could use the interface. Good. So I could use the interface. This is my token, this interface of this contract, and I can just get the past votes. I see your comment there, you let me. I'm going to get to the second bullet point just now, Maya. I'm going to get the past votes from this voter, right? And I need to pass a target block number. I have received it here in the constructor, and I have stored it in this state variable in line 16. So I can pass it here. With the address in the target block number. Remember, I'm going to get these past votes in a fixed time in the past. That will be the date of my snapshot. Okay. Questions here? So it's very similar to what we did in the token sale challenge. It's very common to find this kind of thing. But what we want to do actually is get the remaining vote power, okay? But we're going to do that in a while. Let me already pointed that out. The question here, Dante?
Yeah, sorry. Real quick, why does, say like vote power and there's an underscore after it, and winning proposal, there's a underscore after it?
Because it's one of the returning values. So it's just a naming convention. Anyone reading that function would instantly detect that voting power is something that is going to return. Okay. So I should require that the get vote power of the MSG sender to what? The getting voting power of this MSG sender should be what?
An amount, the amount.
Higher or equal than this amount, right? Otherwise, I can give an error. Tokenized ballot. Voter is trying to vote with more votes than it has. Something like that. So I require the get voting power to be higher or equal than this amount. And let me call it out very well. We need to get the remaining voting power, right? Because the person might have voted already in this ballot. Get remaining voting power. So the vote power should be voting vote. That's not very good naming choice. Sorry about that. But the remaining voting power should be the vote power that the person has minus the amount this person spent, right? How to keep track of amounts per person? Something that would map this number of spent voting power per address. Do you know any technique that would allow us to do that in Solidity? And then when you suggest that, I'm going to finish today's lesson because we don't need anything else. What's the name of the feature that can map an address to a number? Some type of variable that can do this mapping. A variable that can map the amount of votes that each person, each address has spent in that ballot. Marco, very good suggestion. We could create a mapping. Could create a mapping here. Mapping from address to uint 256 called vote power spent. Let's make it public. Every time a person would vote, I can increase this. So vote power spent for that person, for the MSG sender, would increase for that amount too. And I would decrease it here from the vote power spent for this voter. Okay. So get remaining voting power is going to pick the voting power of that person minus the amount that it has already spent in that smart contract. I'm going to keep track of the expenses here using this mapping, and then I can require this correctly. Okay. That answers your 2 bullet points there, Vladimir. Very well noted. Arda, we have a time for a very quick question.
Wouldn't this be tracking all of the voting power the person spent throughout, like in every block added?
Yes, in every block added inside this smart contract. Inside this same smart contract. And my intention here is that you test this out within the weekend. Okay, you are going to complete this contract together. You're going to code this together. You're going to have the scripts, the test to test this out. And you are going to create one script for deploying, and then another script for minting voting tokens, which you test this out, picking the parameters. One script for delegating voting power. Then another script for deploying the ballot after you self-delegated, okay, with a block target number that would allow you to vote. Otherwise, you would have 0 voting power. Then you can cast votes. Then you can check the voting power. Then you can check the winning proposals. Okay. My idea is for you to test this out in this weekend. Okay. In the last weekend, the ballot was given. In this weekend, the tokenized ballot, you are going to build it like we did in the last minutes, and we're going to explore it all out. Okay. Yes, Encode checks those submissions. Okay. If you want to get feedback, you can just open GitHub issues with your questions or your test and I'll give feedback there. I answer those issues every day or maximum every couple of days. Okay. Okay, so count on me. If you have any issues or any questions or things that are still not very clear, let me know. We can pick it up, I think, within this weekend. Okay. We are above lesson time already. Thank you very much for participating today. Anything, let me know. We keep in touch through the weekend, and we talk again on Monday. Thank you, people. Have a good one.